In this lesson, we're going to go over analyzing arguments. Specifically, we'll learn about the two different types of reasoning, construct a Venn diagram to analyze an argument, and determine whether an argument is valid or invalid or sound and unsound. This lesson combines what we've talked about previously with logic and logical fallacies, as well as Venn diagrams. So first, we're going to talk about inductive and deductive reasoning. Inductive reasoning goes from specific examples or premises to a general conclusion. Typically, this is how kids start to reason and view the world. So for example, I was working with, it was a class of like 3 to 5 year olds, and there were 2 teachers in there named Tina. So when the third teacher walks in, the child goes, "Are you Tina too?" So the child, from 2 teachers being named Tina, assumes or concludes that the third teacher has to be named Tina as well. Same thing with this picture we have here. We know that bluebirds fly, hummingbirds fly, cardinals fly, therefore all birds must fly. Well, nope, we have this ostrich here who doesn't fly. So inductive goes from specific examples to a general conclusion. Inductive reasoning only takes one example or one counterexample to disprove the conclusion. It's so for instance, in this case, since ostriches don't fly, also penguins don't fly, this conclusion that all birds fly is not true. The next type of reasoning that is a stronger reasoning is deductive reasoning, which is going from something more general to something more specific. So premise, all doctors are intelligent. Another premise, Dr. Oz is a doctor, therefore Dr. Oz is intelligent. So this type of reasoning, which we'll talk about, this is a valid argument, which means that the conclusion follows from the premises, but whether it's sound or not depends on whether you think all doctors are intelligent or that Dr. Oz is a doctor. Okay. So evaluating inductive arguments. So inductive arguments do not necessarily prove their conclusion, so they're evaluated based on strength. Remember, inductive goes from specific examples to general. So in order for an inductive argument to be strong, you need to have a lot of good quality examples. An argument is weak, such as if the conclusion is not well supported by its premises. So for instance, you have 2 or 3 examples of flying birds, therefore all birds fly. It is not a very strong argument. It's what would be called a weak argument. Evaluating deductive arguments. So you look at the two, we're going to talk about valid and sound. So an argument is valid if its conclusion must follow from the premises, regardless of whether the premises or the conclusion is true. And so it's valid if it has to follow. An argument is sound if it is valid and all of the premises are true. So if an argument is invalid, it doesn't matter whether it's sound or not. You can just skip that step. Okay, but if it's valid, then we talk about sound or unsound. So again, going back to Dr. Oz, some may think that this is a sound argument and some may not. There is some subjectivity to soundness, whereas if an argument is valid or not, that is something that logically follows. Okay, so we're going to use a Venn diagram to test the validity of deductive arguments or deductive reasoning. So we're going to draw a Venn diagram that represents all the information contained in the premises. And these are what you'll see are going to be subset Venn diagrams. And then we'll check to see whether the Venn diagram confirms the conclusion. If it does, then the argument is valid. If it does not, then it's not valid. Example 1, construct a Venn diagram to test the validity of the deductive argument. Use X to represent whales. We'll always tell you what represents X. Okay, so all fish live in water. So you have to determine if water goes here and fish goes here, okay, or the other way around. So check it from what you know about subset Venn diagrams. Fish is a subset of things that live in water. Is that what the premise says? Yes, it does. So this is the correct way to construct. Let me erase this and do the wrong way. If you said fish lives in water, this means that everything lives in water. Everything that lives in water is a fish, which is not what the first premise says. So it was the other way around. This is lives in water. Should use a different color. And then fish. Premise number 2, whales are not fish. So think about what this means. If whales are not fish, that's all we know. So that means whales could be here or here based on this premise. Since whales could be here or here based on knowing that whales are not fish, we put the X on the edge of the circle. Conclusion, whales do not live in water. With where X is, that represents whales, can we conclude that whales do not live in water? In this case, no, we can't. They may live in water or they may not, based on the premise. It's important that when we're determining the validness of an argument that we're going from the premises that were given and the conclusion that we're given to determine whether it's valid. So this is not valid. Okay, and so we don't even have to talk about soundness. Example 2. Construct a Venn diagram to test the validity of the deductive argument. Use X to represent Carlos. Premise 1. If a person lives in Chicago, then the person likes windy days. Premise 2. Carlos lives in Chicago. Conclusion, Carlos likes windy days. So taking from the premise 1 is how we construct our subset Venn diagram. If a person lives in Chicago, then a person likes windy days. Which one is a subset of the other? We have likes windy days, and lives in Chicago. I'm just going to abbreviate it. So what this subset is saying is if you live in Chicago, then you like windy days. Carlos lives in Chicago, so our X represents Carlos. Carlos lives in Chicago, so our X should be inside of this circle. Carlos likes windy days. So do the premises support the conclusion? In this case, it does. X is on the inside. Carlos lives in Chicago. Everyone who lives in Chicago likes windy days. So this would be a valid argument. Is it sound or unsound? Depends on what you think. Example 3, construct a Venn diagram. We're going to use X to represent aspirin. Premise 1, a narcotic is habit forming. Premise 2, aspirin is not habit forming. Conclusion, aspirin is not a narcotic. So we build our Venn diagram from premise 1. A narcotic is habit forming. So when we're building the Venn diagram, is everything habit forming a narcotic or are narcotics habit forming? Okay. So we have habit forming. There are other things that are habit forming as well, like food or video games, etc. And in this case, we're talking about a narcotic. Premise number 2, aspirin is not habit forming. Conclusion, aspirin is not a narcotic. So when we're determining where the X goes, if aspirin is not habit forming, it has to be outside of the habit forming circle. Because the habit forming circle is here. If aspirin is not habit forming, then aspirin is outside of that circle. So our conclusion here is that aspirin is not a narcotic. Is that supported by the Venn diagram? In this case, it is. This is a valid argument. Thank you for watching. If you have any additional questions, please feel free to reach out to me.